Welcome to The Explainer. Today, we're taking a pretty dark, highly cinematic biological journey. We're going to look at a workout from the inside out, tracking the epic, microscopic life of a single muscle fiber as it gets put through the absolute ringer and how it eventually comes out stronger on the other side. Okay, let's dive right in by completely reframing our perspective. So often, we view muscle fatigue, that awful burning, shaking sensation, as a biological failure. We think, oh man, my body's giving up. But looking at the actual science, we need to view fatigue not as a failure, but as a beautifully orchestrated cellular construction project. Think about it. To build a massive new skyscraper, you've got to do some heavy, noisy demolition first, right?
So phase one, the immediate energy drain. To really understand this, our chronological journey has to begin the exact second we start moving. We're going to zoom way down deep into the microscopic level of the muscle, down into the sarcomeres. Those are the basic building blocks of your muscle fibers, just to watch this immediate energy drain unfold.
Now, our bodies basically operate using three distinct sequential energy systems. When you lift a heavy weight or do a hard sprint, your body doesn't just use one type of fuel the whole time. It literally shifts gears. First, it taps the ATP-PC system for that immediate explosive power. Then it transitions into anaerobic glycolysis, which breaks down glucose without oxygen for those moderate efforts. And finally, for the long haul, the aerobic system kicks in, using oxygen to metabolize your carbs and fats.
But here's the catch. That explosive ATP-PC system, it's completely depleted in a mere 10 seconds. Just 10 seconds? When those local energy stores run dry, your body is instantly forced to scramble. It desperately shifts gears to those secondary fuel sources just to keep you moving.
So as those intracellular energy reservoirs run dry, specifically your ATP and muscular glycogen, waste products start to rapidly pile up in the muscle fiber. We see a huge accumulation of chloride and potassium ions. And that potassium actually builds up around the muscle fiber and literally alters the cell's membrane potential. Why does that matter? Because it prevents the release of calcium, which is the exact chemical trigger your muscles desperately need to physically contract.
Which brings us to phase two, when the brain says, stop. The local muscle cells are clearly struggling down there, so the central nervous system has to get involved. Picture your brain and spinal cord as the body's flickering electrical grid, carefully monitoring all this chaos happening down in the muscle.
And this brilliantly illustrates the two-front war of fatigue. On one side, we have peripheral fatigue. That's what we just talked about, where the local muscle fibers are running out of fuel. But then, on the other side is central fatigue. And this is wild. Sometimes your muscle hasn't actually given up at all. Your brain has just defensively stepped in and stopped sending the signal to contract.
So the crucial point here is that neural fatigue is actually a protective mechanism. In untrained people, especially when you hit extreme upper limit forces, the nerve signal simply weakens. The muscle just stops listening and ceases to contract. It's basically the brain dimming the lights to protect the structural integrity of your tendons and fibers, and it often does this before you even feel acute pain.
All right, let's step into phase three, the great lactate plot twist. This is where we encounter arguably the biggest biological myth in fitness history. For decades, we've blamed one specific molecule for all our fatigue and suffering. Get ready, because this is going to blow your mind. We've all heard that lactic acid is the enemy, right? Well, it turns out this is a massive myth. It was born way back in 1902 from some seriously flawed experiments by a guy named Otto Meyerhoff. He basically stimulated frog muscles in a jar without oxygen until they completely failed, noticed a buildup of lactate, and just concluded it was a toxic waste product poisoning the muscle. And crazy enough, that myth has survived for over a century. Enter Dr. George Brooks and his lactate shuttle theory. His lab discovered something absolutely revolutionary. Lactate transporters aren't just sitting on the outside of the cell. They're actually inside the mitochondria, the powerhouse of the cell. This completely changed the game. Because the truth is, lactate isn't toxic waste at all. It's actually a glowing biological fuel shuttle. In fact, it is the highly preferred fuel for your heart, liver, and brain during intense exercise. Dr. Brooks even coined the term lactohormone because lactate acts like a hormone. It actively switches on over 600 genes responsible for muscle adaptation, literally commanding your cells to build more mitochondria. How cool is that? And here is the ultimate plot twist. Remember that potassium buildup we talked about earlier? The one that stops muscles from contracting? Well, lactate actually counters the inhibiting effects of potassium, so it doesn't cause fatigue. It actually outcompetes other fuels to rescue your muscle fibers during intense stress, actively helping them continue to fire. It's literally the hero of the story, not the villain. Okay, so you finish the workout, the lactate clears out, but 24 to 72 hours later, you can barely walk down the stairs. Sound familiar? Welcome to Phase 4, microdamage and muscle soreness, where the structural toll truly sets in. That heavy, painful stiffness you're feeling, it's not from lactic acid hanging around. It's actually delayed onset muscle soreness, or DOMS, and it's primarily caused by physical microtrauma to the muscle fiber, particularly during eccentric contractions. That's when a muscle is forced to lengthen under a heavy load, like when you're slowly, agonizingly lowering a heavy dumbbell. Let's walk through this damage cascade. As the muscle lengthens under that load, it physically tears at the microscopic level, creating tiny lesions right at the sarcomere Z-line. This damage causes calcium to leak and accumulate where it definitely shouldn't be, which inhibits cellular respiration. In response, your body sounds the alarm, rushing inflammatory cytokines. These are chemical messengers like IL-1 beta and TNF-alpha straight to the site. This whole process is known as the enzyme efflux theory. That excess calcium basically acts as a massive demolition signal, activating enzymes called proteases that literally degenerate and clear away all the damaged muscle proteins. It basically turns your muscle into a highly inflamed cellular construction site. And all this swelling and chemical cleanup, it intensely stimulates your nociceptors, your pain receptors. So that pain you feel, it's just the signal that the cleanup crew is hard at work. But hey, demolition is only half the job, right? To actually get stronger, we have to transition away from the fiery inflammation of the gym and into the cool, restorative state of Phase 5, the ultimate rebuilder. I'm talking about sleep. During deep sleep, your body acts as a master contractor. It reads all those inflammatory cytokine signals from your workouts, it utilizes the essential hydration and nutrients you've carefully consumed throughout the day, and it finally begins to patch up those disrupted sarcomeres. During this incredible sleep rebuild sequence, your body perfectly balances the hormones necessary for growth. It's spiking human growth hormone and testosterone while simultaneously regulating stress hormones like cortisol. It's the time where your brain consolidates the actual motor skills you practiced, and your immune system restores itself so it can manage all that inflammation properly. Conversely, without this critical downtime, you are accumulating a massive biological debt. Your muscle fibers are just left stranded, bathed in inflammation, with no repair crew anywhere in sight. Inadequate sleep blunts your cognitive function, wrecks your hormone profile, and completely halts the repair process. It significantly increases your risk of injury and overtraining syndrome. So, to summarize this epic journey, a successful workout is basically a perfect biological cycle. You stress and break down the sarcomere, your body signals the heroic lactate shuttle to keep you fueled, you trigger a localized inflammatory response to clear out the microscopic debris, and finally, you deeply hydrate and sleep to rebuild the tissue stronger than it was before. Which leads us to one undeniable conclusion about human physiology. The gym is just the stimulus. It's just the breakdown. The real magic? Growth doesn't happen in the gym. It happens in the dark. So the next time you feel that deep, lingering muscle soreness, ask yourself, are you actually giving your body the restorative dark it needs to finish the job? Thanks for joining me on this explainer, and I'll see you next time.